on our Linux box here, and it is really simple. All you have to do is to do apt get install, and we're going to install Clang 12 because that's the latest version at the time of recording this video. If we do this, we're going to see that it's going to install. I already have it installed here, but if you don't have it installed, it's going to install on your system. And this is going to give you all the tools you need to compile with the Clang compiler. On this particular Ubuntu system, these installs are going to be installed in my user bin directory. So if I cd there and do an ls to show everything in here and scroll up, we're going to find all the versions for Clang. You see I have multiple versions, Clang 10, 11, 12, and we have Clang++, variant of this, I think we do. Okay, we have Clang++ and Clang here. And this is going to do what we want. We have the Clang compiler and the GCC compiler installed on our system here. Now, if you want to get the latest version of GCC installed on your system, one easy way I found is to go through a package manager called Homebrew. Let's search for this. Right? If you search for this, you're going to find it. And if you want, you can install it on your Linux system. And when you install it, it's going to be basically there, ready to use. And to install it, I think there's a command there, install Homebrew. Let's do this, install here. And if we do install, we should find a link to install this. Let's find a link. I think they have a link you can copy. It is this little thing here. You can copy it, paste it in your terminal, and it is going to install Homebrew on your system. And when you have Homebrew installed, you can go through it to install the latest version of GCC. For example, if we search for Homebrew GCC in our search engine here, we're going to find all the information to install this through Homebrew. And you just have to do brew install GCC, and this is going to install this on your system. And you're going to see that it is going to install the latest version at the time of recording this video. So this is what you should do. For example, if we go back to our Linux box, we can do, let's cd into our home directory, and we're going to say brew install GCC. And it's going to tell me that it is already installed because I installed this. But if you don't have it installed, it's going to install it. And you do this after you have gone through the steps to install the Homebrew package manager on your system. And you do that by just copying this link and pasting that in your terminal and hitting enter. And it's going to give you directions on what you can do to get this properly installed on your system here. So this is really cool. So if you want the absolute latest version in GCC, this is one way you have to get a hold of it without really going through the complex steps to build the compiler yourself on Linux. Okay, it is taking some more time here. I am just going to kill this because I already have the latest version of GCC here. If I do GCC 11 on Linux and do version, I am going to see that I have 11.2 and it was installed through Homebrew. And if you let this run to completion, it's going to install this on your computer. We don't have to wait for this. So now we have the latest version of GCC on an Ubuntu system. We also have the latest version of Clang. This completes our tutorial on how to set up compilers on Linux. We are going to stop here in this lecture. This one, we're going to install Visual Studio Code on the Linux system. And then in the next one, we're going to link Visual Studio Code to these compilers and be able to use Visual Studio Code, type code, and compile our programs using these two compilers here. So go ahead and finish up here and meet me in the next lecture. In this lecture, we're going to see how to install the Visual Studio Code editor on a Linux system. And again, we will be working on our Ubuntu 20.04 system here. So let's head over to the website for Visual Studio Code and download our binary and install it on our Linux system here. Okay, so here we are at the website for Visual Studio Code. You can get there by searching for Visual Studio Code in your search engine, and you're going to land here. And all we really have to do is go down to find our download links. We're going to see that for Debian and Ubuntu, we can download here. But you can also find something specific to other distribution. Okay, so we are going to grab the 64-bit version of Debian Ubuntu here because that's my system. And you're going to find whatever makes sense for your distribution. So let's grab this here. We're going to grab the link. So if you click on this, This is going to kick off the download process, and you will see this downloaded on your system. And once you have this downloaded, you're going to install it. And in Ubuntu, you can just double click on this to install it, or you can install it like you install any Debian package on a Linux system. For example, if you are unsure on how to install Debian packages, all you have to do is do a simple search. So let's do google.com and go there. And we're going to see how to install Debian packages on Ubuntu 2004. So this is our version here. And you're going to find a lot of instructions on how to do this. It's going to be really simple. So we can go down and find a way to install. So all you have to do is say sudo dpkg, say I, and pass the name of the package. And this is going to install Visual Studio Code on your system. Once you do this, you will have Visual Studio Code installed and you will be ready to start it and use it on your system here. Once it is installed, you will have the ability to come in your system here, for example, and say code dot, and this is going to open a Visual Studio Code instance on your system. Let's wait for this to come up so that you really see this. Okay, so this is going to open Visual Studio Code on your system, and you can start using it like we will do in the next lecture. Okay, once you have Visual Studio Code installed and started up on your Linux system, the very first thing you need to do is to install the extension that is going to allow you to do some C and C++. And to do that, you will come to this tab here that says extension. And in our search box, you can start typing C and C++. And you are going to have an entry that says Microsoft here. So please select this. And this is going to be the extension you need to install. You're going to click on install and it is going to install. And this is what enables Visual Studio Code to do some C++ programming. And this is really cool. If you want, you can check out how to use it on Linux, and you're going to have instructions on how to do this, but we will do this in the next lecture and show you how to configure Visual Studio Code to use the compilers that we have installed in a previous lecture. So we're going to tell Visual Studio Code to use our Clang compiler, we're going to tell it to use our GCC compiler, and we will have the flexibility to come to terminal and choose which compiler we want to use. And we're going to do all this in the next lecture. So go ahead and finish up here and meet me there. In this lecture, we're going to configure our Visual Studio Code editor to use the compilers that we just installed in a few previous lectures. So we will be able to type our code in our Visual Studio Code editor just like we do here. And we will pass the code through the compiler to generate a binary that can in turn run on our Linux system here. This is what we want to do. So we want Visual Studio Code to use the compilers that we installed. So let's head over to our Linux box and do this. Okay, here I am on my Linux box. This is the current directory where I am at. This is where I am going to do my things here. So I am going to create a folder and call it a template project. Let's do this. We're going to say mkdir. And we're going to say C++20 template project. I think this is going to do. Or we can even say CPP because I'm not sure the plus signs here are not going to give us a problem. Let's play it on the safe side, and we are going to create this folder and we're going to cd into this folder. Okay, once we are in this folder, we're going to open this folder in Visual Studio Code. And the easiest way to do that, once you have Visual Studio Code installed, is just to type code and type dot, and you will basically be telling the operating system to open Visual Studio Code in the current folder here. So I am going to hit enter, and this is going to kick it open. And I trust this folder because I just created it, and we are in our project here. The very first thing we're going to do is to create a main CPP file. So let's do that. And I did that by clicking on the plus icon here, and I typed in the name of the file, and I am going to put in some dummy code here that we want to use our starter code. We're going to say iostream, and we're going to put in our code here. We're going to say main, and again, you don't have to type all this. If you want, you can get the code from the resource section on the lecture, so you can copy the code, paste that in here, and be on your merry way. Because we haven't really started learning about C++, we are setting up the environment, so don't stress yourself here. This is just some simple code to test our compilers to see if they support C++20 because we want to use the latest standard we can get our hands on here. So let's do equals, type exactly what I type here. So we're going to say 10, and we're going to put this weird operator and say 20, and we want to see if this madness here is greater than 0. This is what we want to do, and we're going to say stdc out and say result. Okay, so type exactly what I type here, and as we progress in the course, we're going to make sense of all this madness we see here. So now that we have a CPP file containing the code for our C++ program, we want to compile this. And we need to tell Visual Studio Code which compiler it's going to use to compile this program here to give us a binary that we can run. So what we're going to do is come to terminal here, and we're going to say that we want to configure tasks. And a task is really a set of instructions you give to Visual Studio Code on how to take your C++ project and turn that into a binary that can run on that system here. So that's what we want to do. We want to tell Visual Studio Code which compiler it's going to use. We're going to configure task here, and you're going to see that it's going to discover many compilers on my system here. You see we have Clang 10, Clang 11, Clang 12, and we should also have GCC 11. If we keep scrolling down, we're going to find these little guys here. I have many compilers on this system, so I am going to choose the GCC compiler, which is installed through Homebrew. This is what I'm going to choose here. You say it's saying G++11, but if you have access to G++10, you can also use that. It's going to work with what we want to do in this course here, mostly. So I am going to choose the best I have in terms of GCC, and this is going to set up an entry in our tasks.json file to build and run this program here. And that's what we're going to do. Okay, you see it is using this particular compiler, and one thing we can do before we try and build this, we can change the label here to make it a little bit more descriptive. So we're going to say build with GCC 11.2.0 if I am correct. And this is all. We can save this and we can close this JSON file. And if we bring up a terminal window, we can do that by hitting terminal here and choosing new terminal. This is going to open up the current location. For example, if we do pwd in this terminal here, let's use lowercase. I think that's what it wants. We're going to see the location here. This is my project. So to build, I can come to terminal and choose run task. And I am going to choose the task to compile with my GCC installation here. If I choose this, it is going to kick off the build process, and you're going to see that the gibberish I have here is not supported because the compiler is not configured to use C++20. So all we really need to do is go back to our command and tell it to use C++20. And we can do that by passing a specific instruction to the compiler to use C++20 like we do on line 10 here. So we're going to say std equals C++20. We are going to save this a little bit, and I really wanted you to see this problem here because many people are going to forget this. And we're going to try and build again, making sure we are selecting the main CPP file here. So let's go to terminal, run task, and use our compiler and wait for it to do its thing. You're going to see that the build now finished successfully. And if we come back to our terminal here and do ls, we're going to see that we have a file called main, and if we run it, we should see a 0. So let's say main here. And if we run it, we're going to see a 0, meaning that our program is running and working correctly. We are able to compile a C++ project on a Linux system here. Now, if you want to see how I came up with the information to use the task.json file, please come back to the extensions tab here and choose the C and C++ extension. We're going to click on this, and we're going to see all the instructions on how to use this guy on a Linux system here. So GCC on Linux, we can choose this, and we're going to see all the information here. Now, you can read up on all this if you want, but what I am going to do is go to Visual Studio Code and show you exactly what you need to do to get this to work. What I want to do in there is set this up to compile everything in my... What I want to do is to set... What I really want to do is to set this up so that it compiles every single CPP file in my directory here. And I can do that by putting in a set of instructions I had prepared beforehand. So we're going to tell it to compile in C++20 mode. We're going to tell it to compile every single CPP file in this directory. And then we're going to specify the output file name for our binary. Now, this is code I used on Windows. I need to adapt it to be specific to Linux. So let's see what they say in the documentation there. And we can scroll down a little bit, and we're going to see that they use backslashes here. So that's what we're going to use in Visual Studio Code to play it safe. So we can say this, a backslash, and this is a backslash. And we will try and build this, and we're going to see what happens here. This is going to build our project in C++20 mode. We're going to be building every single CPP file in the project, and the output will be called rooster. This is what we want to do here. Let's save this up. And I am going to close this JSON file, and I will bring up my terminal by coming to view and saying a terminal here. And I can remove the main.exe file or the main executable I had in there. If I do ls, you see it's gone. But now if we try and compile with the GCC compiler, we're going to see what happens. You see the build is good, and we have a binary called rooster, and we can run it here. If we do rooster, we're going to see it run and give us a 0, and this is really all we need to do. Now, we have this working for our GCC compiler, but we want the same for our Clang compiler, and we want the flexibility to be able to switch compilers by coming here and just selecting the right task. So let's do this. We're going to configure Clang. We're going to come to terminal. We want to configure a task, and we're going to choose the best we have in terms of Clang. That happens to be Clang ++12 here. So we're going to choose this. And this is going to add an entry in our tasks.json file. We're going to change this to say that we want to build with Clang. Let's do that. We're going to say build with Clang. I think we have 12.0.1 if I remember correctly, but we can ask our terminal here. Let's go to terminal, and we're going to say Clang ++ and 12, that's the version, and we're going to ask it what's your version. It's going to tell us in detail, and if we wait, we're going to see this spit out on the terminal here, and this happens to be Clang version 12.0.0. So that's what we're going to say in our file here, build with Clang 12.0.0, to be super clear on this. And this is really all we need to do is put in the instructions to build in C++20 mode, exactly what we did for GCC here. So I am going to copy this and put that in my arguments here. I am going to take out whatever I had in there. I am going to put in my new things, and let's see if this compiler works now. We're going to save our tasks.json file and come back to the CPP file. We're going to bring up our terminal window, and we're going to clear and remove rooster because we want to build a new one with our Clang compiler. And we will come to terminal, run task. Now we're going to choose to build with Clang 12.0. We're going to fix this in a minute. But if we do this, we're going to see that our build process is going to start. It's going to be building with our Clang compiler. It's going to be using C++20. It's going to be building every single CPP file in this location here. And the output of the build will be a binary called rooster that we have right here. So the build is good. If we do ls, we're going to find rooster, and if we run it, it's going to say 0, exactly as we expect here. And we have Visual Studio Code properly configured to use our two compilers, the Clang compiler and the GCC compiler. Let's come back to our configuration and change this to say 12.0.0 to be super clear on the version we have. We can close our JSON file here and come and try to build again. If we do terminal and run task, we will have our compiler here. Ignore all these things. I think Visual Studio Code is going to give you duplicates, but you can choose the version that says what you want, and it is going to work. So we're going to choose GCC. Oh, we are saying GCC, but we want Clang here. So let's say that we want to build with Clang. We're going to go to terminal and run task, and we want Clang 12.0.0. This is right here. So we're going to select it, and it's going to build successfully, and we will have our binary here. If we run it, it is going to say a 0, and this is really what we need to do here. So this is really all I had to share in this lecture, showing you how you can configure Visual Studio Code to compile using the compilers that we have installed. Another thing you can do to make your experience better is come back to View and select Command Palette here, and you can do C and C++ and edit the configurations through a user interface. And if we do this, you're going to see that this is going to create a CPP properties JSON file. So this is where we can configure what kind of IntelliSense, what kind of compiler is going to be used. We can do all these things here. So we're going to leave it to the default. It's on our Linux system. It's going to be using GCC 11, which is the best we have in terms of GCC. But one thing you should note in this course here is the C++ standard we want to use. So we want to use C++ 20, and we want Visual Studio Code to give us IntelliSense or format our main CPP file based on the C++ 20 standard here. That's what we can achieve with this. So once you have this in, you can come and close this. And if we go back to the main CPP file, you see now that this is no longer flagged as a problem with squiggly lines. Visual Studio Code is properly understanding what is happening here. And this is something you can do to make your experience a little bit better. Okay, now that we have this project set up and ready on Linux, we're going to be reusing this as a template project every time we start something new on Linux. So every time we want to create a new project, we will grab this entire folder. So for example, we will come to our terminal here and go up a little bit. So CD and go up one level. And if we do ls, we're going to have our C++ 20 template project. We will copy it and rename it to start a new project. And that's going to give us all the configuration that we did. We don't need to reconfigure the compilers or whatever. It is going to work right out of the box. And that's really what we did here. We set up a template project that we will be reusing all over again in the course as we progress, learning about C++ 20. I am going to stop here in this lecture. In the next one, I am going to show you how you can set up a development environment on the macOS system. Go ahead and finish up here and meet me there. In this video, I am going to show you how to install C++ compiler on your Mac OS system. And we have a bunch of options on the Mac. We can install the GCC compiler, we can install the Clang version of the Apple company, or we can install the Clang LLVM version. All these are options, and I will show you how to install these. I don't have access to a Mac device, so I won't really be able to install Xcode and show you, but I think you can manage if you are using a Mac system. It is nothing complicated. You just have to go to the Apple Store and click on Xcode, and it is going to install. For GCC and Clang LLVM, I will show you how to do this using the Homebrew Package Manager, which is also going to make this super easy. Okay, so let's head over to our browser, and we have a good link here from DigitalOcean on how to install and use Homebrew on a macOS system. This is a really validated link. You can see that right here. And you can read up on this if you are using a Mac system. I am going to share the link here in the resources section of the course. And to use this, we will go through the Mac OS terminal, and it is nothing complicated. You can search for it and open it up. And after you do this, you will have to install the tools needed to build things on the Mac OS system, and that's going to install Xcode here. So grab the command here and run it in your terminal, and this is going to install everything you need. And after you have this installed, you're going to install Homebrew. I do recommend coming up to the website here for Homebrew and clicking on this copy icon here. This is going to copy the entire thing, and you can copy this, and once you copy it, it is going to give us a green tick here. And you can go in the terminal on your macOS system. I am using a Linux terminal here. And then you're going to paste this command in here and hit enter. Once you do that, you will be prompted to put in the password. It's going to tell you that it needs to install Homebrew. And you're basically going to wait for this to finish. I have to warn you, this is going to take some time. Even if you have a good internet connection, this is going to take some time. So be patient here. When it's done, it's going to tell you that it is finished. And you will be ready to install the GCC compiler and the Clang LLVM compiler through your Homebrew installation here. I am not going to click on this because I already have this installed on my Linux system here. Let's go back to the link and see what they say next. So after you paste that in, it's going to install. And after that, you will see that Homebrew is going to be installed on your system. And you can use Homebrew to start installing and upgrading packages. You can really read up on this. But what I want you to see is that you can use Homebrew to install the GCC compiler and the Clang LLVM compiler. So if we come to the search here and say GCC Homebrew, we're going to find instructions on how to install this. So all you need to do really is to say brew install GCC. This is going to install the latest version of GCC on your Mac. If we come here and say LLVM or Clang, let's say Clang, and we can find that right here, LLVM, and it is going to give us instructions on how to install this. And all you have to do is brew install LLVM, and this is going to install these two compilers on your Mac system. So once you do that, you will have them stored somewhere. Let's go to the install link, and we're going to see that Homebrew is basically going to be installing things in your user local directory on a Mac device. Please tell me if this is true for your case. And if you have a problem, we'll try and go through that and fix that up. So if you are on a Mac, I would really recommend going through this to install Homebrew. Once you have that installed, you will go through that to install both the LLVM compiler and the GCC compiler, and that's going to give you the latest versions for these compilers. To find out if they will install, you can go in your user local directory and you can hunt for these compilers, and you're going to find binaries for them and start using them to build your C++ applications here. Okay, so by now I am going to consider that you have both GCC and Clang installed on your Mac system. The next logical thing to do is to want the Apple version of Clang, and I think that's going to come as part of Xcode here, and it is going to come as a result of running the command that we did before. I think it was this little command here, which is going to install everything you need from the Xcode IDE. So this is all I had to share in this lecture. Again, I apologize, I don't have access to a Mac device. But if you have a problem, you can tell me and I will try to help you out and get this sorted out. We are going to stop here in this lecture. In the next one, we're going to see how we can install Xcode on your Mac device. Go ahead and finish up here and meet me there. In this video, I am going to show you how to install the Visual Studio Code editor on your macOS system. Please know that you can also use other IDEs like Xcode or CodeLight to do C++ development. But Visual Studio Code is going to be our main editor in this course here, and I would recommend to install it so that we are doing consistent things. That's going to reduce chances for you to get confused. So we are going to head over to the website for Visual Studio Code, and to get there we can just type Visual Studio Code in here in our search engine, and we will have a link here that we can use to download our things. So we're going to go down and find download links for Windows, Linux, and Mac. Please use the Mac download button here, and you're going to download the binary and install it. I think it is going to be in the download folder by default, so all you have to do is drag that up in your installation directory so that it becomes a runnable application. After you do that, you're going to run it, and it is going to run, and you will have a user interface like this with Visual Studio Code opened up. Once you have that up, you will need to install the C++ extension, and what you need to do is come to the extensions tab here and type C and C++ in here, and you're going to have an entry for Microsoft. Click on that and install this extension on your system, and your Visual Studio Code instance is going to be ready to handle some C++ development. And this is really all I had to share in this lecture, showing you how you can get this installed. Again, I apologize, I don't have access to a Mac device, so I used my Linux box running inside Windows subsystem for Linux to show you this, but this is good enough, I think. If you have a problem, you can tell me and I will do the best I can to help you out. For now, we're going to stop here in this lecture. In the next one, I will try and show you how to set up a Visual Studio Code to use the compilers that we installed in the last lecture. Go ahead and finish up here and meet me there. In this lecture, I am going to try and show you how to configure Visual Studio Code to use the compilers that we installed on our Mac system in a previous lecture. So we want Visual Studio Code to be able to pick up our GCC compiler and use it. We want it to pick up our Clang compiler and use it. We also want it to pick up our Clang compiler from Apple and use it to build binaries that we can then run on our system here. So let's see how to do this. I have to say I don't own a Mac device, so the best I can do here is describe the process to you. And if you have a problem, you can tell me. I will do the best I can to help you out. Okay, so once you have Visual Studio Code installed, you're going to create a folder somewhere and open Visual Studio Code from that folder. And what you will basically do is use the terminal to navigate to a location. You're going to create a folder. You can even call it CPP template project. You're going to hop over into that folder and then open Visual Studio Code from that folder here. So for example, we can hop over into CPP and run code and say dot. That's going to open Visual Studio Code in that folder. And from that folder, you will create a main CPP file by clicking on the plus button here. And you will create a CPP file, call it main CPP, and you can put in the content here. And once you have this, the next task is going to be to set up a compiler to build this little thing. So once you have this project, you will come to terminal. I think there's going to be a terminal menu somewhere, and you will choose configure tasks. Once you do that, Visual Studio Code is smart enough to scan your system and find any compiler you have installed. The first thing that is likely to be found is the Apple Clang compiler. So you're going to find a Clang ++ compiler. So you can choose that and you can use that. For the Apple Clang compiler, we are lucky. We even have a tutorial on how to do that. So if we click on our extensions tab here and choose our C and C++ extension, if we scroll down, we're going to see a link on using Clang on macOS here. This is going to give us all the instructions we need to use Visual Studio Code with the Clang compiler from the Apple company. So if you scroll down, you're going to be able to read up on all this. But what I really want you to see is the configuration file. You're going to see that it's going to be using the Clang compiler from the user bin directory. And this is mostly going to be the Clang version from the Apple company. And sometimes you don't want this. So if you want to use the Clang version that we installed through Homebrew, I think you will need to go through the user local directory because that's where Homebrew is going to put it. You're going to see that that's going to be the location here from our tutorial. And you're going to hunt down for the Clang compiler and find your binary. And that's what we're going to be using next. But for the first time, if you want to use the Clang compiler from Apple, this is the configuration you need. And all you need to do in this case is change this to C++20. Now, once you have this configured, you will have the ability to come to terminal. Let's show our files here. You will have the ability to come to terminal and run tasks and choose the compiler. That's going to be the Clang compiler from Apple. But you can also configure other compilers, and all you really have to do is choose them in the list here. And you're going to have a configuration file, a tasks.json file to be exact. Let's show that up here. And that's going to give you the instructions you need to build this. And in most cases, you will just need to be careful about the path to the compiler. So for example, if you are using the GCC version you installed through Homebrew, you're going to find that in your location. You're going to make sure that's the correct one, and you will put in these instructions here to tell your compiler to build every single CPP file in the directory here. This is what we do. If you use Clang, you're going to have something like this. And again, I am describing this to you because I don't have a Mac available to me right now. And if you have a problem, you can tell me, we can try and sort this out. Okay, and by this time, you will have the ability to use your Visual Studio Code instance and compile C++ programs using either the Apple Clang compiler, the LLVM Clang compiler, or the GCC compiler. And all these are going to be compiling in C++20 mode. Again, to build, you need to make sure you have the file selected and choose whatever compiler you want to use. For example, if you want to use Clang 12 from Homebrew, you're going to select that, and it is going to be used to build your project. And you will have the ability to run your project just like we do here, and it is going to work. Let's make sure we are running Rooster here, our binary, and it is going to run and print a 0, and this is going to work. Again, I am really sorry I don't have a Mac device available to me, but this is what I have to work with now. If you have a problem on a Mac device, please tell me. I will do the best I can to help you out. In this lecture, we're going to explore the option to use online compilers if for whatever reason we can't install a radio compiler on our system. And again, the goal is to be able to turn the code we type into what looks like an IDE into a compiler and get a binary that we can run and see the output of. There are a few online compilers that are very popular within the C++ community. Onebox is one of them. There is also Compiler Explorer and Koliru, but there may be other ones out there if you do research on your own. We're going to go to the browser and actually check each of these out. Okay, here we are in our browser. Here I am on onebox.org. And you see that it really looks like an IDE. Inside we have the code we've been running all along to make sure that it compiles with C++20. On the left here we have a few options. We can select which compiler we want to use. You see that there is a couple of GCC versions. You can see that this is a really nice way to test things across GCC versions. You see we have Clang 12. So if you want to test Clang out, you can select it. Let's actually try this. So we're going to use Clang head and try to compile this. So let's hit enter and see if Clang 12 supports C++20. And you see that it really works. Clang version 12 should support C++20 like this. Let's go back to GCC because that's what I like. And you can try putting different things in your C++ code to see if the compiler actually responds. For example, we can say stdcout, hello there, stdendl. And if we run, we're going to see the message output here. Another good thing with these online compilers is that you can share this code and anybody will be able to look at the code here and run it. So this is a really good way to get help from your instructor. So I do encourage you, if you run into a problem, come and use one of these compilers and send me the link. The way you can send the link, you can hit on share here, this button here. You're going to get a URL that you can copy and send to anybody, and they will be able to see your code just like we're going to see here in a minute. Okay, you see that it is the exact same thing, and anybody on the internet will be able to see your code and try to find whatever the problem is and help you out very fast. Onebox is one compiler. You can play with the options that we have here. You can load different libraries. You see they have a lot of Boost libraries, but this is of no interest to us right now. You can play with it and see what you like about it. Another one is Koliru, which is another online compiler. You see, it doesn't have a lot of options like we had in Onebox. For example, you cannot change the compiler. It's going to be using G++. But if we hit compile, link, and run, it's going to run our code, and we're going to get the output here. Again, we can try and change this so that you know I'm not lying to you. So we can say stdcout and say the sky is blue. stdendl. If you want, you can hit Ctrl+ on your browser, and it's going to make this a little bigger. And if we compile, link, and run, we should see the sky is blue in the output window here. This is really all you can do with Koliru. And if you like it, you can donate to the developers. I think we have the same thing on one box, but it is in Japanese, so I can't really read this. Okay, another one is Compiler Explorer, which is a really good one. The main purpose of this is really not giving you the output. It is actually seeing assembly code that is generated for your C++ code. This is something a little bit advanced for our purposes here, so we're going to ignore this. We're just going to be using it to test our code with some of the popular compilers. If you look here on this Dropbox, you see that they also have a lot of compilers. You can use different GCC compilers. I think they even have MSVC. How cool is this? So you can use a lot of compilers, GCC, Clang. You see we have a lot of Clang compilers. We have Clang 11 here. So this is a really good way to try things out. We're going to come back to GCC 10.2. And notice that I passed the flag of C++20 to be able to support C++20. Again, if I come here in my code and say stdcout, the sky is white, don't worry about these errors. They're going to go away in a minute. Let's wait for the program to compile. You see that it is compiling. Let's wait a minute. The sky is white and everything is fine. If you don't see this output here, it is possible that you didn't check this checkbox, run the compiled output. So come to this Dropbox and make sure this is checked, and you should have a window like I have here. Compiler Explorer also allows you to share your code with people on the internet. Let me see if I can find the option to share. You come to this Dropbox and you get a link here that you can copy. I'm going to copy this and open a private window in my browser here so that we know that it is some other browser that is going to be opening this link and getting access to the same code we have in Compiler Explorer. And this is going to be pretty cool. And you see that we get Compiler Explorer privacy. We're going to close this. And you see that we have the same code. We can try modifying this code. For example, we can take out this third line here. It's going to start compiling. You see that it is compiling. And it is going to give us the output that we expect from this. So this is a really good tool to try out. If you want to share your code with some people that are not close to you, this is a really good way to do this. It is also good to try out different compilers. For example, if you don't have a GCC compiler, you can try it out here and see if it does things. For example, we didn't install Clang on our system, but we can try it out and see if it runs our code. But make sure you pass the correct flags here because you are responsible for this. For example, if you pass the flags that don't work, you're going to get errors. For example, if we say hello here, we're going to get weird errors and unrecognized command line option std hello. But if we say C++20, it is going to work. So make sure you pass the correct options. In this lecture, you're going to write your first C++20 program, and we're going to start and attempt to understand our program. Let's hop over to Visual Studio Code and actually do that. The first thing we want to do is to set up our code so that we can open that in Visual Studio Code. We're going to start from our C++20 template project that we set up in the last lecture. And I'm going to be doing the projects for this chapter in this folder here. So we're going to do our very first C++ program. So what we're going to do is go inside our C++20 template project. And I noticed that we actually left in the build files we don't want. So what we're going to do is remove this main file and this VC140 thing. We don't want these here. And we're going to copy the main CPP file and the .vs code folder. We're going to copy these things and we're going to put them in our first C++ program folder. And we're going to open this folder in Visual Studio Code. Visual Studio Code is not opened up. You see that I have my developer PowerShell opened. If you want, you can open Visual Studio Code directly without going through this if you're not going to be using the Visual Studio compiler, but I want to have the option to use that compiler, so this is how I am going to open my Visual Studio Code instance. I am going to type code.exe to open this up. I'm going to hit enter and Visual Studio Code is going to open, and it is going to open whatever we did in the last lecture. We don't want this project because this is a template project from the last chapter. We're going to close this folder, go to File, and hit Close Folder. And we're going to open the new folder we want to work in. We're going to go to File and hit Open Folder. We're going to go to the location where our project is. So you're going to go where yours is. I'm going to browse to mine. And I'm going to go in the current chapter and choose 3.2 first C++ program. I'm going to select the folder. It's going to open up, and you're going to see that our settings from the last template project are still valid here. They were copied over. If we open the main CPP file, it's going to be the main thing we had in the last lecture. So we have the option to run task. You're going to see that we have our two compilers available, and this is really good. We are ready to start using this. Let's try and build this with GCC, and we're going to have our binary created. We can click in the terminal here, and if we want to open the terminal again, we have the option to come in terminal and new terminal. This is going to open this up. If we do dir in the terminal, we're going to see our program generated. We can remove this thing here and say rmrooster.exe and remove this. We can clear, and we have a clean project we can start learning from. Okay, now we have the project in. It is building successfully. Let's try to understand the code we have in here. The first statement we have is this include IOStream thing. This is a feature C++ offers to load the pre-built libraries that we can use. IOStream is specifically going to help us print things to the console. We've seen that we can, for example, print hello world if we want. Let's take out all these things in here and say std : cout. This is coming from IOStream, and we're going to put two less than symbols. We're going to open two quotes, and inside we're going to type hello world. And we're going to go outside the quotes and do two less than signs and say std : endl and put a semicolon. This is going to print things on the console if we run this program. So if we run this program, the first thing we need to do is to build this program. So we can come to terminal, task, and we're going to build it with GCC. And after we've built it, we can hit enter to close the terminal. And we can do dir to see the content of the folder. You see that a program has been generated. We can run it. And if we run it, it's going to say hello world. This message is coming from this statement here. And we have this statement because we have included IOStream. To really make this super clear, we can try to remove this line that says include IOStream. And the moment we do that, you're going to see that this tab says we have problems. And if you open this tab, you're going to see the message, namespace std has no member, cout, namespace std has no member, endl. This is because the C++ program doesn't know what std_cout means because we don't have the library included. And you also see that we have these squiggly lines to make it really clear that we have a problem. So to really be able to use this, we have to include a third-party library that brings these features into our program. And that's what the include statement here is really doing. So let's bring this in. And we're going to say IOStream again. And let's wait and see that the problem goes away. And one thing you should really know is that we don't have a semicolon at the end of the IOStream statement. We don't need to put it there, but many C++ statements need a semicolon at the end. Okay, I think this really makes it clear what the include statement here is doing. The other thing we have in our program is this int main parentheses curly braces thing. This thing here is called the main function. A function in C++ is a block of code that does a lot of things, but the main function here is special because it is the starting point of your C++ program. We also call the main function the entry point of a C++ program. And what that means is that if you open the program, the main function is going to be the very first thing that is going to run, and the things are going to be executed in the main function in order. So the statement on the top is going to run first, and the statement after that, until we hit the end of the function. So this is what we mean here. To really drive this home, we can come here in our main function and say std number1 and say std_endl. And by the way, this endl statement is going to print a new line. We're going to see it in effect in a moment. Let's actually take it out so that we can see its effect. We're going to also do std_cout number2. And what this is going to do is to print number1 and number2 on the terminal. Let's build this program. And if you want to build the default task, you can hit Ctrl+Shift+B for it to happen very fast. But I am always going to come here so that it is really clear what I am doing. Our program should be generated now. If we try to run it by typing rooster.exe, and again we can hit the up arrow button on our keyboard so that the last command that we run from this terminal runs, and this is going to speed things up a little bit. So if we run this program, it should say number1 and number2 as you see here, but these two things are cramped on one line, and the reason is we are not printing new line characters after we print number1 and number2. And we can solve this problem by putting in two less than symbols and saying std::endl. This is going to put a new line character after number1. We can build again for our new changes to take effect. After we do that, we click on the terminal, we hit enter, we hit the up arrow button. If we run, it's going to say number1 and number2 on two separate lines because we are printing a new line character after number1. I really hope this makes sense. Please do take some time to play with us, because if this is the first time you're doing this, some things might not be clear, and the best way to really make sense of this is to type code, run it, and see the effect of what you type by running your program. So let's do this a couple of times. We're going to do std::endl after the statement for number2. We're going to do std::cout number3. And we're going to do std::endl. To really show the problem again, we're going to take out std::endl on the number2 line. We are going to build. The build is going to be successful. We're going to click in the terminal, hit enter, hit the up arrow button, run the program again, and you're going to see it's saying number1. It's going on the new line, printing number2, but we're not jumping to the new line from number2. So number2 and number3 are going to be cramped on one line. That's what we see here. We can solve this again by putting in a new line after number2. Let's do std::endl here, and this should solve the problem. Again, let's build. We're going to run our build task. The build is going to be successful. We're going to hit the up arrow to run the program. If we run it, it's going to say number1, number2, and number3, and this is really good. Now it should be clear that statements in the main function are run in order from top to bottom, and that the program is going to end when it hits the end of this curly brace that englobes our function. We're going to have a chance to learn more about functions in detail later in the course, but we are just getting started and we need to start somewhere. So that's why we're doing this main function thing here. Another thing you can do is return from the main function, and in many examples you will see people do return 0, something like this. And this is a way for the main function to send the message to the operating system if it finished successfully or if there was some kind of problem. We're not going to go into any more details about the main function because that's really too much for now. We are just getting started. We are trying to get a feel of how C++ works. The main message here is really that you should be able to print things to the console using stdcout. You should be able to print a new line after your message using stdendl. This stdcout and stdendl thing come from the iostream library that we are including here. If we don't include this library, we're going to have problems because our C++ program is not going to know where they are coming from. So we should really put this in if we want to use these features. And we can return from a function to let the system know, the operating system, if the program finished up successfully or if there was some kind of problem. And again, this project is using the templates we've done before. And this is really all we set out to do in this lecture, trying to make sense of the main function in C++. To really practice these things, I would challenge you to write a C++ program just like this that is going to print your name 10 times. Try to do that. And if you have a problem, please do ask me and I will do the best I can to help you out. This is really all we set out to do in this lecture. I hope you found it interesting. We're going to stop here in this lecture. In the next one, we're going to start and learn about comments in C++. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about comments in C++. Comments are a way to put some messages in your C++ code that are really meant to be read by humans. And one way we have to do comments in C++ is through this \\/ thing we have here. This is going to comment out the line, so the compiler is really not going to care about it. It's going to think that it is something that is meant for the developer to see. So this is a one-line comment, and this is how you do it in C++. You can also comment out a block of code in your C++ code, and this is something that comes in quite handy many times. You put your comment in a \* and a * like this. This is going to comment things out in your code, and the compiler is really not going to care about this. Let's hop over to Visual Studio Code and actually play with this. So here we are in the folder that is going to contain our code. The first thing I'm going to do is go through the template project. I'm going to copy my files and I'm going to go up again, and we're going to be learning about comments. So I'm going to put this in the folder on comments. I am going to close whatever folder we have opened in Visual Studio Code, and I'm going to browse to the location where my project on comments is. My project is in this folder that is named 33 comments. I'm going to open the folder, and if I open the main CPP file, I'm going to find the starter project. We're going to remove this const eval thing because we're really not ready to understand this yet. It was in here to help us test that our compilers support C++20. So we're going to remove this, and we're going to put in a message that says hello world. You already know how to do that from the last lecture. So we're going to say stdcout hello world, and we're going to say stdendl, and don't forget this semicolon at the end. If you do, you're going to have problems. So make sure your code looks like this. Try to build it to make sure it's working fine. This is going to run the GCC task to build. We can click on the terminal here, and it's going to close the terminal. And we can open a new terminal here if we want. If we do dir, we're going to find our rooster program inside. We can run it, and it's going to say hello world. We already know to do this from the last lecture, and in this one we are going to be learning about comments. The first thing you can do is use // so let's do that. And let's put some message here. This brings in the iostream library. This is a nice message that is going to give some more information about this statement to whoever might be reading this program. And this is called a one-line comment. You can really put this wherever you want in your C++ file. You can go in the main function, for example, and say this is going to print hello world to the console or the terminal. We can really put this anywhere. We can even put it after the return statement here, and really put in whatever piece of information we think is going to make sense to whoever is going to be reading our program. Okay, this is how you do a one-line comment. You can also do comments across different lines. And the way you do that, you put that in the /* and go down and say */ like this. And whatever is going to be in the middle here is going to be a comment. This is usually called a block comment. You can put in whatever you want. So if you have a piece of text that you would like to use as a comment in your program, this is one way you can do this. One thing you should know though is that you cannot nest these things. But before we do that, let's try to build our program to really show that there is no problem if we have these comments in. The build is successful, and if we click on this terminal and hit enter and hit clear to clear things out in the terminal, we can try to run our roster program, and it's going to say hello world. You see that all these green lines, which are comments, are really not affecting the program. All the compiler is going to care about is this include thing. It's going to care about the main function here. It's going to ignore these green things. It's going to be like these green lines that are our comments are not in there. This is the effect comments have on your program. And we're going to be using this a lot in this course. One thing you should know though is that you cannot nest these block comments. So if you try to do something like this and say this is one comment, and come again and say this is another comment, you see that we have problems already. Nesting is not allowed. You're going to get a compiler error, and we're going to learn more about these errors in the next lecture. But don't do this. Don't nest these block comments. If you do that, you're going to get some confusing errors, and this is going to be the cause for them. So don't nest your block comments. It's going to give you headaches. Okay, this is really all we set out to do in this lecture, learning about comments in C++. You can do one-line comments on a single line like this. You can do block comments to comment out a block of text. You can't nest your block comments because that's going to give you a lot of problems. You don't want that. And really use comments wisely and don't overdo it because it's going to turn your program into a novel. And I don't think people want that. So use this feature when you need it to give some more information about your code, and don't overdo this. We are going to stop here in this lecture. In the next one, we're going to learn about different kinds of errors and warnings you can see in your C++ program. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about errors and warnings in your C++ programs. There are three kinds of errors or warnings you can get. You can get compile time errors, you can get runtime errors, and you can get warnings. But what is really meant by these things? Remember, the ultimate goal of every developer or every C++ developer, in our case here, is to be able to generate a binary executable file from the C++ code. And we have to run the code through the compiler to be able to do that. And one thing you should know is that there is a set of requirements that the compiler enforces on our code for it to be able to compile successfully. And those requirements are the rules really that we have to follow in our C++ program. And if we break those rules, we're going to get problems. And these problems are going to come in the form of compile time errors, runtime errors, or warnings. Let's look at compile time errors in detail. Here we have a simple C++ program that has a few problems. We have forgotten to put the semicolon at the end of our stdcout statement here, and the compiler is going to freak out because of this. If we compile this program, we're going to get a bunch of errors, and the IDE is going to show us this problem. Some IDEs are going to give you different errors. For example, here I was using CodeLite, and it was saying error expected semicolon before return or something like this. So this is a compiler error, and if you have this kind of errors, your program is not going to compile, compilation is going to fail, you're going to get this error, and you're not going to get your binary executable. And when you have this, you basically have to go back and fix this problem, compile again, and when you get rid of these problems, the compilation is going to succeed. This is what a compile time error is. Another thing you can have is a runtime error. This is not going to cause a compile time error. The compilation is going to succeed, but when you run the program, it's not going to do what you intended it to do in the first place. For example, you may want it to print green on some user interface. It's going to print gray or whatever. It's really not going to do what you want. So it's a logical error that you have in your program, and you have to fix it to get rid of this. And another thing you should know is that sometimes these runtime errors can cause your program to fail and terminate immediately, and we say that the program has crashed. We're going to see an example of this in a minute. The last kind of problem you can have in your program is a warning. This is a problem that is not serious enough for the compiler to halt your compilation. Compilation is going to succeed, but this is basically the compiler telling you you are doing something that has some problems, and you should really fix it before it becomes a serious problem. So that's going to be a warning. For example, here you see some compilers can warn you when you divide stuff by 0, and we're going to see how this works. The main message in this lecture is that you may have problems in your program, and they are going to come in 3 forms. Some are going to be compile time errors, some are going to be runtime errors, some are going to be warnings. We are going to hop over to Visual Studio Code and actually play with this. Okay, here I am in Visual Studio Code. The first thing I'm going to do is to set up the template project we're going to be using in our project here. The project is going to live in this folder, errors and warnings. I am going to copy over the files, and I am going to go in the current project we're going to be working on, and I am going to open this folder in Visual Studio Code. I am going to go to File, Close Folder. I am going to close this one, and I am going to open our new project. I am going to browse to it. The project is this one. I am going to select it and select folder, and it is going to open up in Visual Studio Code. I am going to close this welcome screen and open our main CPP file. We're going to get rid of this const eval thing. This is a C++20 test thing we had in. We don't really need it now. We're going to get there in due time. What we want to see is compile time errors. We're going to put in our stdc out statement, hello world, as we usually do. We're going to end this stdendl, and we're going to remove the semicolon on purpose. And if we try to compile our program like this, we're going to get a compile time error. This is what we want to see. So let's try and build our program. We're going to run the task to build with GCC. And you see that the build fails. We're going to get a bunch of errors in our terminal. It's going to say in function int main expected a semicolon before return. It's going to try its best to tell you what the problem is, but sometimes these errors can be really confusing. In this case, it is really easy because we introduced this error on purpose. So we're going to fix it in a minute. But before we do that, I want you to see this problems tab. It is where the problems are going to show up in Visual Studio Code. So you should see your problems in here or through the terminal here. Okay, one thing you should know is that when you have a compiler error, compilation is not going to succeed and you're not going to have your binary file, which is what you really want. So to fix this problem, we're going to put in our semicolon here. We're going to build again. We're going to go to terminal, run task. We're going to build with GCC. And this time you're going to see that compilation is going to succeed and we have our program here. We can run it through the terminal here. So we're going to click. The terminal is going to go away, but we can open our own. And if we do dir, we're going to see our files in here and we can run our program. We can say rooster. And if we run, we're going to have hello world. So I hope this really makes it very clear what a compile time error is. So this is one kind of error you can get. The other one is a runtime error. And this comes in the form of things that don't work as you really expected. So let's say we are trying to do some computation in our program. We try to take 7 and divide this by 0, for example. And this is a statement that is allowed in C++. So let's try and build this and see what we get, because this is a common scenario where we have runtime errors. We're going to run the task to build with GCC. Okay, if we do this, you see that build finished with warnings. We didn't get a compile time error and our build was successful. So to really prove this, I'm going to go back in our directory. I'm going to do dir. You're going to see that rooster is there. I'm going to remove it. I'm going to say rooster.exe. This is how we remove stuff from the command line. When I do this and do dir again, the executable file should be gone. So let's try and build with this statement n, and you're going to see that we get a warning and not a compile time error like we had here. So we're going to go to terminal, run task. We're going to build with GCC, and you're going to see that we're going to have our executable here, but we had a warning and it's saying that division by 0 was detected in our program and it is a recipe for disaster. So why is it a disaster? Let's try and run this program. So we're going to dir to prove it's here, and we're going to run it. If we run it, it's going to say hello world, and it's going to end. Let's try and actually use our own terminal to see if we have a better chance of seeing the problem here. So I'm going to reveal in Explorer by clicking on main CPP, and I am going to try and open a terminal window here, PowerShell, that we open ourselves. We've done this before. This shouldn't be new to you by now. So we're going to do dir in here, and we're going to try and run the program, and it's going to run. So it's not really giving us a runtime error here because we're not capturing this or trying to use the result of this division here. We're just doing the division, which is a problem. So let's try and capture this. We haven't learned about variables yet, but what we're going to do now is do int value, and we're going to assign the result of this division to this value. And let's try printing the result of dividing a number by 0. So we're going to do stdcout, and we're going to say value, and this is how you can print a value out on the console. Okay, now that we have this n, let's try and build. We're going to run task and build with GCC. We're going to get the same warning, but if we try to run the program, we're not going to get what we expect. Let's run rooster.exe. We expect it to say hello world and print the value, but you see that it's really struggling to print the value, and it gave up and ended immediately. So this is one example of a runtime error that you can face in your program. There are many other kinds that we're going to see as we progress in the course. Here, we are just trying to raise your awareness on these problems so that you can know how to fix them when they come up. Okay, so this is all I can share with you now about runtime errors. We also had a chance to see that this is also going to give you a warning. And Visual Studio Code here is also helping out, telling us that we may have a problem. It's turning the main CPP file yellow, and it's saying that there is one problem in this file. And if you go here, you're going to see that we have a warning here. Okay, so this is one way you have to see this. So this is not recommended to do, so we're going to comment this out. Okay, this is really all I had to share in this lecture. We had a chance to look at compile time errors. We also had a chance to look at warnings and runtime errors using this example. If you get a warning, it is a message the compiler is giving you that you should really look it up and fix the problem before it becomes more serious. Compile time errors are going to cause your compilation to fail, and that's a really good thing because the compiler is going to stop you from generating a binary that doesn't really do what you expect it to do. So that's a good thing. But sometimes the compiler won't give you a compile error, and you have a chance to run into a runtime error, and that's really bad. So be careful about these things, and when you have problems, Visual Studio Code is going to show you the problem in Terminal or in this Problems tab, and you're going to be able to fix it up. We're going to stop here in this lecture. In the next one, we're going to learn a little more about statements and functions. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about a little more about statements and functions in C++. A statement is a basic unit of computation in C++. You can say that it is the smallest thing your CPU can execute in your program. Every C++ program is a collection of statements, so you're going to have a bunch of statements that are organized in a certain way to achieve whatever it is you want. And statements in C++ must end with a semicolon. We saw in the last lecture that not putting that semicolon is going to result in a compile time error. Here is a basic sample C++ program that we're going to use to learn about statements. In the main function here, we have two variables declared. We haven't really learned about variables, but they are a way to store data in your program. And here we are storing two decimal numbers. One is called first number, the second is called second number. We can do something with these variables that we have in our program. For example, we can add them to have another variable in our program, and we can print that. So you see here we are saying stdc out, the sum of two numbers is sum. So this is going to print 21 because it's going to add 12 and 9, and the result of that is going to be displayed on the terminal if we run this program. What I really want you to notice is that this int first number equals 12 thing is a statement in C++, so it must end with a semicolon. The line here with second number is also a statement, so it must end with a semicolon. Every single line we have here in the main function is really a statement, and it must end with a semicolon. If we don't put the semicolon in place, we're going to get a compiler error. Okay, one other thing that is really important to keep in mind is that statements are executed in order in your program, and the order is from top to bottom. If we go back to our program here, so the first statement is the one with first number here. 12 is going to be stored in memory when this statement is executed by your computer. And we're going to go to the second statement with second number, and we're going to keep going until we hit the end of the main function, and the return statement is going to execute. And when the main function returns or terminates, we're going to get the return value sent to your operating system, and it's going to know if your program ended successfully or with a problem, and the operating system is going to know what to do with that information. Execution keeps going until we hit the end of the program, or if there is any other condition causing for the program to terminate. And we're going to have more details about these things later. I just want you to know that the statements are executed in order in your main function. Another concept I really want you to have an idea about is the concept of functions. A function is really like a machine. You give it input and it's going to give you output. If we look at the operation here to add first number to second number, we can consider first number and second number as input to the function, and sum is the output of the function. We can visualize that like this. So we have a first number and a second number. We pass that into our machine, which is really a function, and we're going to get the result of this function in a return value or something that we get out of the function as our result. C++ has a special syntax we use to define functions. This is our function to add numbers. On the left, we have an integer, which is code name for a whole number in C++. It's a number without decimal points, and it's a whole number. After that, we have the name of the function, and we can name it whatever we want. And after that, we're going to have the list of parameters that we can pass to the function. And this is going to work as the input to the function. After you do that, you're going to have a pair of curly braces. The one is here, the other is here to the end, and within those curly braces is going to be the body of the function. Inside the function, you see that we are declaring a variable which is called sum, and we are storing the sum of first number and second number in this variable, and we are making this function return the sum as the result, and we're going to be able to capture it if we call this function in a function like main. You're going to see how this works in a minute. A function must be defined before it's used, so you can't really call a function you haven't defined first in your C++ program. And here is a slightly complete program to really put all these ideas together. We have our function to add numbers. It takes two numbers, first number and second number. It's going to add them up and store the result. And we're going to return sum to be used by whoever called this function. And if you look in our main program, we have a statement here. We're going to store the result of add numbers in the sum variable, and we pass first number and second number in the function, and we're going to have that result stored in here. Here we also call the function with direct numbers. You see that we pass in 34 and 7, and we're going to print out the result here. This is the basic idea I want you to have about functions. They are reusable pieces of code that group together a bunch of statements to do whatever it is we want to do in that function. One benefit about functions is that we can reuse the code here. If you look here, we are calling this function multiple times without really rewriting these statements that are inside the function. I know some of these concepts might be cryptic to you right now. We are going to go to Visual Studio Code and try this in code, and you're going to see exactly how this works. Okay, here we are in our folder where we are storing our projects. I am going to grab the code from the template project. I am going to put that in the current project, which is statements and functions. I'm going to paste that in here, and I am going to open this up in Visual Studio Code. I am going to close the project we have right now, and I am going to open our new project. Let's browse to its location. I am going to open the project on statements and functions. Let's open this folder in Visual Studio Code, and we're going to have our starter project here. I am going to take out whatever we have in the main function and take out this const eval thing. We don't really need it. And we are going to try and define two variables using two statements. We are going to say int first number, and we're going to put in a value, let's say 3, and we have to remember to end this with a semicolon. So this makes our statement. We can encode this in a comment to make this pretty clear. We're going to also define a second variable. So we're going to say int to mean that it is a whole number. It doesn't have decimal points like 2.5. It is a whole number like 1 or 7 or 10. So we're going to say second number. We can give it a name, and let's put in a 7. We're going to store these values in our program, and we can print these values out. Let's print them out first. So we're going to say stdc out. We already know how to do that, and we can say first number, and we can chain these output statements and say the first number is first number. You can do that stdendl, and you can notice that Visual Studio Code is really helping out in auto-completing things we have in our program. Let's print the second number to really practice this. So if we do std, you're going to see that it's going to give us a bunch of options we can choose from. If you want, you can scroll through this with your mouse, or you can just type whatever you want to type. So I am going to do cout, and it's going to try and help out. If I really want, I can come on cout here and click on it, and it's going to be auto-completed, which is pretty cool. So we're going to say second number, and we're going to say second number here, and it's going to autocomplete for us, endl, and we can try and compile this program. Before we do, I want you to guess what we're going to get when we run this program. Give it a guess. We are then going to go to terminal, run task, and we're going to build this with GCC. The build is going to be successful. We're going to open this in our terminal. The terminal goes away, no problem. We're going to open it again, and we are going to go in our folder and do dir, and you're going to see that we have rooster.exe, our program. We can run it, and it's going to say first number 3 and second number is 7. This is what we have stored in these variables. And the benefit of storing your data in variables is that you can change the variables and let the rest of your program really do the same things and pick up the data that you have in those variables. For example, we can put 13 in the first number, and if we build again, this number is going to be picked up by this code, and we didn't need to go in and manually change data in these stdc out statements here. Let's build so that we can see this, and we can close this by clicking, and if we run rooster again, it's going to say 13 and 7. Play with this a couple of times until you really feel confident. And if you have any problem, don't hesitate to ask me. I am going to do the best I can to help you out. Now that we have these numbers stored in our program, we can add them up. Let's say int sum. We're going to declare another variable, and we're going to say it's equal to first number plus second number. And we're going to end this with a semicolon. And we're going to print the sum out. Let's do stdc out, and we're going to say the sum is sum. We're going to print our variable here, and we're going to print a new line character with stdendl. We're going to build our program so that our changes are reflected in our binary here. So we're going to go to terminal, run task, build with GCC. The build is going to be successful. We're going to press any key. We are going to click here in the terminal, and we're going to hit enter and run rooster again, and we should see the sum, and you see it says the sum is 20, which is what we expect. Now, we are doing the sum here, but it would really be better if we're not doing the sum in the main function here. What if we actually took this code and wrapped it in a function that we could reuse wherever we want? We have seen how we can declare a function. So let's do that. We're going to follow the same structure we saw in the slides earlier. So we're going to say int. This is going to be the return value, or what we get out of the function. Then we're going to put in the name of the function. We're going to say add numbers, and we're going to pass in the parameters. The parameters can really have any name you want, but you have to specify the type of the parameter first. So the parameters are also going to be whole numbers like 1, 5, 7, or whatever you want. And we're going to say first param, and the second is going to also be a whole number, an integer, and it's going to be second param. Okay, after we do this, we're going to specify the body of the function, which is going to be between these curly braces. I am going to jump to the next line so that this is really easy to see. So I am going to define our sum variable inside the function. It's going to be a whole number, and I can call it whatever I want. So let's call it result, because it's going to be the result of this function, and the result is going to be the sum of first param and second param. Okay, I hope this makes sense, and we're going to end this with a semicolon, because every statement in C++ has to end with a semicolon. After we have the result, we need to give it back to whoever called this function, and we're going to do that with a return statement. And we're going to return the result to whoever might have called this function here. Now that we have the function, we can actually use it. We're going to go back in our main function, and what we're going to do is to reuse this sum variable and store in whatever is returned from our function. The syntax for that is going to be sum, and we're going to say equals, and we're going to say add numbers, and we can pass in whatever two numbers that we want to add up. Let's pass in 25 and 7, for example. We would expect this to give us 32. So if we print the sum again, we can just copy this statement that prints the sum and reuse it here. Let's align this a little bit. And I want you to take a guess at what we are going to get from this program right now. We have these two numbers, we are adding them up. If we get here, this should print the first number, which is going to be a 13. So here we expect to get 13. And by the time we hit this second number statement, we are going to print the second number. It's going to be 7. If we get here, we're going to print whatever is stored in sum. And in sum, we have the sum of first number and second number. So this should print 20, right? And here we are doing another sum of two numbers, but we are using a predefined function that we have here before the main function, because you have to define the function before you use it. Okay, if we add 25 and 7, we are going to fall into this function, and it's going to add those numbers up, and we're going to get a 32 in here, and that's what we're going to return, and it is going to be saved in this variable. If we print it out, it's going to give us 32. I hope this makes sense. Let's build and run our program, run task, build with GCC. The build is going to go fine. We're going to go back to our terminal here. Let's clear so that things don't disturb us and bring in some confusion. We're going to run our rooster program, and exactly what we have here, we have a 13 from the first statement here. We have a 7 from this statement here. We have a 20 from this sum here, which is here, and we have a 32 that we got from this function. The good thing about functions is that we can reuse them. Now that we know how to use it, we can use it again, and we can say sum equals add numbers, and we can say 30 and 54, for example. You add them up and you're going to get the result. So we're going to print the result, sum, and we're going to put in the sum. I really want you to take some time and play with this statement so that these things make sense. It's really not that difficult, but you just have to wrap your brains around how C++ defines these things. So we have this statement, and we are adding 30 and 54, so it should get an 84 after the 32 here. Let's build. We're going to run the task to build with GCC. We're going to click on the terminal here and hit enter. Let's clear so that we don't have things disturbing us, and we're going to run our program, and we have our trusty 84 here. I really hope this makes sense. And as a bonus, I'm going to show you that you can also call things in the std_cout statement here without having to store them in some predefined variables. And sometimes this comes in handy. So you can say std_cout, and we're going to say sum, and you might say add numbers right in here, and you're going to say 3, for example, and 42, and this is going to give us a 45. That's what we should expect to see after 84 here. So let's build and run the task to build with GCC. The build is going to be successful. We click on the terminal here, we hit enter so that we see our terminal with output. We're going to clear so that we see our output without noise. We're going to run our program, and we're going to see a 45 here. I really hope this makes sense. The whole point of this lecture was to make you aware of statements and function. A statement is the most basic unit in your C++ program. It basically lives on one line, but it can also spread across different lines. But we're not going to look at that here. Maybe we're going to see that later in the course. Statements are executed in order, so when our main function gets to be run by the computer, it's going to go from the first statement, second statement, third statement, and it's going to go until it hits the end. And we can see that here in the order in which our numbers are printed, it is going from top to bottom. We have also seen that we can split our code in different functions and wrap whatever functionality we have in a function. We have seen the basic concepts on functions. A function has a return value, it has a name, and you have to give it the parameters, and you put the body of your function within these two curly braces. As an exercise, I would challenge you to do a function that multiplies two numbers and call it in the main function here to see the result. If you have any problem, please do ask me. I am going to do the best I can to help you out. This covers all we set out to do in this lecture, and I hope you found it interesting. We're going to stop here in this lecture. In the next one, we're going to see how we can input and output things from our C++ program. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about how we can get things in our program and get things out of our program. And that's basically input and output to and from our program. We have actually been doing this all along. We have been printing things from our program to the console. And with this technique, you can really think of std_cout as a highway that goes from your program to the terminal. You can basically think of it like this. Data is going from your program to std_cout, and it's going from here to the terminal. And from this, you might get an idea why these less than signs kind of point to the left. Because data is going from your program to std_cout, and these two symbols point to the left. They point to std_cout to signal to the fact that data is going from here to here. I really hope this makes sense, because sometimes these things can confuse people. This is the reason why it's going from your data to std_cout. Data is basically going from your program into std_cout. And std_cout is one way we have to get data from our program to the console. There are many others. We have std_cerr or std_ser. This is what I like to call it. And what it does, it prints errors to the console. We have std_clog, which is going to print log messages. Why do we have these different things? Different programs might decide to format these messages differently because they are different messages. One is a simple message from the program, another is an error. You might want to turn this red to really bring the attention to this message because the user has to solve that problem. Another might be a log message that you want to store in some file or some database. Uses for these things differ, and C++ makes sure to give you different ways to state your intent through the tools that you use. We have looked at std_cout, std_cerr, and std_clog. what does stdcin do? It does the reverse. It's going to take data out of the program and bring that into the program. So let's look at a few examples using these. Here we have an example of printing data from the program to the terminal through cout, cr, and clog. Here we have a hello world message going to cout. Here we have a number going to cout. This is what we've been doing all along. We can also do a variable storing the age, for example. It's a whole number, it's an integer. So we print this out and the message is going to go from the program to cout. So you can think that things are going from the program to stdcout. I really want this to make sense. Okay, if we go down, we're going to see that we can use cr to print errors to the terminal. And we might say something went wrong or something along these lines to bring the attention to the problem. And we can use clog to print log messages, and they work the same way. They all use the stream output operator, and it is going to take data from the program to the output stream, really. This is what we mean here. Here is an example of how you might read data and bring that into the program. Here we have two variables. One is the age. It's a whole number or an integer in C++, and the other is a string. This is a type that allows you to store strings in C++. We're going to learn a little more about this later, but here I want to use it to really make it clear that you can get things from the outside and bring that data in your program. So we're going to let the user type in the last name, and this statement here with cin is getting data from the stream or from the highway through which data comes into our program and bringing that in our program. And here it should be clear that the flow of data is in this direction. Data is going from cin and we're storing that in a variable that we have in our program that is called name. We do the same thing and ask the user to print the age, and they are going to print that, and the data is going to come from cin and we're going to store that in our age variable here. After we collect the data from the user, we're going to print that and we're going to say hello. We're going to print the name and we're going to say they are whatever years old. This is what this program does, and I really hope it makes it clear how data input works through streams in C++. Another thing we can do with stdcin is chaining input. And we can use this technique to grab data in one statement. Look at the program down here to really understand this. We have the same variables, age and name. We let the user type in the last name and age separated by spaces. And we grab the data like this. We first grab the name, after that we grab the age, and we're going to print the same things. And we can chain input stream operators like this to grab the data in one go. And this may come in handy sometimes. Before we try these things in Visual Studio Code, I want to bring your attention to a problem that you are likely to come in contact with, and that is reading data with spaces. What if the user types the name with spaces? For example, you ask me to type my name. I'm not going to type Daniel. I'm going to type Daniel Gakwaya, and your program is going to run into problems. C++ allows to solve this problem using std_get_line, and you use it using this syntax. You're going to pass in the stream where the data is going to go, and you're going to pass in the variable that is going to read the data. And you're going to have this information stored correctly in your program. This might be not making sense yet to you. We're going to go to Visual Studio Code and play with us, and I am sure it is going to make sense. Okay, here we are in Visual Studio Code, and we have our project where we're going to store our files, data input and output. We're going to copy code from our template project, and we're going to put the data in. And I am going to open this folder in Visual Studio Code. So let's close whatever we have now. And I am going to open my folder. Let's browse there. I am on this folder, data input and output. I am going to select that. And the project is going to open up in Visual Studio Code. I am going to jump to my main function. I am going to take out things we don't need. And the first thing we're going to do is printing data. We have already done this, so we're going to practice this a little bit. We can say stdcout, and we can say hello C++20. Why not? And we're going to put an std ENDL at the end, and remember our semicolon. And here I want you to really put in your head that data is going from our program here to stdc out, and stdc out is going to dump that on the terminal. That's how this works. You can also do a variable, let's say int age, for example, let's say 21, and end this with a semicolon. And we can also print the age. We can say stdc out, and we can say age. This is going to be sent to the output stream, and we're going to do stdandl to add a new line character at the end. And we can try and build this before the program gets more complicated. Let's go to terminal. We're going to run the task to build with GCC, and if we hit enter on the terminal here, the terminal is going to go away. We're going to create a new one, no big deal. And if we do dir, we're going to find our rooster program. If we run it, it's going to say hello C++20, and the age is going to be 21. We are successfully taking data from our program and printing that to the terminal. This is pretty cool. And you can think of stdc out as a highway that is really going to take your data from your program and bring that to stdc out like this. We're also going to take the age, it's going to go through stdc out, and it's going to show up here. You can think of this like this. Okay, now that we have used stdc out, we can use stdcr and stdclog in the same way. So we're going to say stdcr, and we're going to say error message, and the message is going to be something is wrong. You may do whatever you want in here. And we have to remember to put a new line character, otherwise data is going to be cramped on one line. We can also use stdclog. It really works the same way, clog, and we can say log message, and we're going to say something happened. And we remember to put stdendl and our semicolon. If we build this program, you might guess what it's going to do. It's going to print these things on the terminal, but this might be useful to terminal programs that support features to format different messages directly. The program is going to know that one message is a simple message, the other is an error, the other is a log message. Let's run our program. But before we do that, let's clear so that we don't have noise here. We're going to run the program, and it's going to say the error message and the log message here. Okay, now what we're going to look at is how we can get data into our program. And data is going to be going in a different direction. It's going to be coming from the terminal and flowing into our program. What we're going to do, we're going to do int age1. This is a new variable, so we're going to put in data, and we're going to bring in a string library to allow our program to store strings. The way we're going to do that, we're going to include string. This is how you do it in C++. We haven't really learned about this type. It's a powerful type in C++, but we will get there when we have more powerful tools to really understand it. We are just getting started here. So what we're going to do, we're going to say std string, and we're going to say name, and we're going to ask the user to print their name and age. You already know how to do that, so we're going to say please type your name and age, and we're going to do stdendl on this. And how we're going to get data in the program, we're going to use stdcin, and we're going to do stdcin, and data is going to be going from the stream to the program. So the stream input operator here points to the right, and the data is going to be going in the name variable because that's what they're going to be typing in first, because that's what we told them to do. So we're going to store the name, and we're going to say stdcin. Data is going to be flowing from stdcin into our age1 variable. Okay, now that the user has given us their information, we can greet them with a personalized message. We're going to say stdcout hello, and we're going to put out their name, and we're going to tell them you are, and we're going to put the age 1 because that's what they're going to give us here, and we're going to say years, and we're going to put an stdendl here. I'm going to grab this and pull this to the left so that we can see our entire program here. That's helpful. So what we are doing here, we are getting data from the user and we are storing that in our variables, and we are printing the message so that the user can see it. I don't want the first things we did here to disturb us when we build and try this out. So I am going to comment this out and comment the first block of code out using block comments. I think this is the first time we use this, and this is going to be ignored by the compiler now, and it is only going to consider this. And this is going to be pretty cool. Let's go down a little bit here and try to build the program. We're going to run the task that built with GCC, and looks like the build is good. We're going to hit enter and we're going to clear so that we are not disturbed by this. We're going to run the program. Let's say rooster.exe. It's going to ask me to type my name and age. My name is Daniel. I'm going to type that, hit enter. It's going to want me to type my age. So I am going to say 33, for example. And it's going to tell me, hello Daniel, you are 33 years old. I put a slash here. We can try and run it again so that I don't have to make that mistake again. So Daniel, that's my name. I hit enter, I say 33. And if I run, it's going to say, hello Daniel, you are 33 years old. I really hope this brings the point home that stdcin is a highway that takes data from the terminal into your program. So this is really what is happening here. When I type Daniel, it's going to flow from the terminal and it's going to go into my variable, which is name here. And when I type the age, it's going to go in my age variable here. And all these happening through stdcin here. Okay, one other thing we can do is grab the data and put that in our variables in one go. So what we can do here is comment this out, and we're going to do stdcin, and we're going to put that in name, and we're going to change these two things and put the other piece of data in age 1. If you run the program, it's going to work exactly the same way, but we are grabbing the data in one line. So let's build to see this in action. We're going to run the task that builds with GCC. We're going to click here and we're going to clear. If we run Rooster, it's going to ask for the name and the age. I'm going to put in Daniel and I'm going to put my age and say 33, for example. And it's going to do exactly the same thing, but we have one compact line. The last thing I want to show you in this lecture is how you can grab data with spaces, because if I try to put in data with spaces here, the program is going to fail miserably. Let me show you this. I'm going to clear and I'm going to run Rooster again. And I'm going to say Daniel. I'm going to put in my full name, and it's really not grabbing the second name, and it didn't give me a chance to input my age, and this is really bad. So C++ provides a way to solve this using std_getLine. So let's say what we are doing here. And before we play with this, we're going to comment out what we had here so that it doesn't disturb us in what we are about to do. So let's come down here and say that we were doing data input. This is helpful here. And we're going to go down and grab data with spaces. So I am going to set up another string, and this is going to store my full name. That's what I'm going to say here. And to grab it, I'm going to tell the user to type in their full name and age. So I am going to stdc out. So the way I'm going to grab the data, I'm going to do std_getLine. You see that we have this function here, and it's going to take an input stream. So stdcin is going to work, and the second parameter is going to be the variable where this string data is going to be stored. We're going to pass in our full name, and this is going to work just fine. And we're going to also grab the age using the same technique we've used before. So we're going to say stdcin, and we're going to store that in our age3 variable. Once we have the data, we can greet our user using the same message we had before. So I'm going to copy that, if I can do that, and I'm going to paste that here. I'm going to bring this to the same location. It's going to be full name here, and it's going to say age 3. And let's try and build. We're going to terminal, run the task to build with GCC, and we have a problem because we forgot our semicolon. See how these problems might come to you? So we're going to put in our semicolon. And another thing I really want you to see is that you can bring these things to the next line if they turn out too long like we see here. So I can, for example, put this to the next line and it is going to work just fine. So what I am going to do, I'm going to try and build again, run task to build with GCC. You see that the build is good. I'm going to bring in our terminal. I'm going to clear so that we don't have noise here, and we're going to run our program. It's going to ask me to put in my full name. I'm going to say Daniel Gakwaya, and it's going to want the age. I'm going to say 33, and it's going to greet me, hello Daniel Gakwaya, you are 33 years old. We are able to bring data with spaces into our program. And this concludes what we had to say in this lecture. I hope it made it very clear what these stdin and stdcout things are. They are basically highways that take data out of your program or bring data into your program, and the way you use them is what we've done here in this course. I would encourage you to play with this a couple of times if this is the first time you're doing this. We are going to stop here in this lecture. In the next one, we're going to try and recap on the C++ development workflow. Go ahead and finish up here and meet me there. In this lecture, we're going to explore the C++ execution model and show you a simplified version of the memory model of your C++ program. Here is how our program looks. It is a simple program. In our main function, it is going to call a simple function that is going to add two numbers. We have seen a program like this before. And when we compile it, it's going to be turned into a binary. This black icon here represents the binary executable, and it is not in the format that you can read with your eyes. If we come back here to what we were doing in the last lecture, we can see our rooster executable binary here. If we try to open it here, you're going to see that Visual Studio Code is going to say the file is not displayed in the editor because it is either binary or uses an unsupported text encoding. So it says, I can't really say this because it's binary. And it says, do you want to open it anyway? If I try to open it, it's going to be just some gibberish because this is binary. It is meant to be read by programs. It is not meant to be by IDEs or text editors like Visual Studio Code. So this is the binary file we have here. I tried to put a simplified version of this program to represent binary so that we can follow it up, but it is not in a form that is readable by any human out there, unless you are a machine. So why is it in binary? Because binary format is easily understandable by your CPU. And we're going to see how your program is loaded in memory and executed statement by statement by the CPU so that you can really understand this. So here is a representation of your program. Here we have our hard drive and we have the program sitting somewhere on our hard drive in binary format, and it's waiting to be run by you by double-clicking on it or opening it in the terminal. And on the left here, we see a representation of the memory of our computer. And when I say memory, I mean random access memory. I don't mean memory on your hard drive. This should be really clear. This is the random access memory of your computer that is running your programs very fast. So when you double-click on our program, or if we open it in the terminal, the binary file is going to be loaded up in memory. And you see it in red here. This is a representation of that. And it is ready to be run by the CPU. By the time the CPU sees in the memory location, it's going to know I have a program to run. And the CPU is going to start running it statement by statement. It is going to start by the top, so it's going to see that it needs to allocate space to store our integer a. It's going to allocate that somewhere on the memory. In yellow here, you see a, and it's going to see that it should store in a value of 10, and it's going to do that. You can see that here. It's going to go to the next statement, and the next statement tells it to allocate space for a value b, and it's going to store in a 5. It's going to go to the next statement. It's a variable called c. It's going to allocate space for it, but we didn't specify a value for c. So what it's going to do is store in some junk value. The value in there is really unspecified at the moment. It's going to jump to the next statement, and what it's going to do is print some things on the console, and it is going to do that. It's going to jump to the next statement, and it is going to print statement 2, and here it is going to notice that it is going to call a function. I don't know if you have noticed, but the CPU has allocated a special memory location for our function. The function doesn't live with our code here or anywhere near the variables that we have here. There might be a huge chunk of memory between these 2 or 3 things. So the CPU knows that it is going to jump to another location. It's going to ask itself, if I jump to that location to run this function, how am I going to come back? And the CPU is smart enough to store the return address. And that's what it's going to do. It's going to say, if I go to that function, I want to come back to the address 6 and run whatever is after this address. So it's going to store 6 in CPU memory, and it's going to jump to the function. It's going to take the first parameter as A and the second parameter as B. So A is 10. The parameter 1 is going to be 10. It's going to take parameter 2, it's going to be 5 because it is B here, and in B we have a 5, and it is going to jump to the next statement in the function, and it is going to add up parameter 1 and parameter 2. After it adds those things up, it's going to return the result to C. We can see that here. Okay, that's what the CPU is going to do. It's going to put the result in C, and the result is a 15. So we're going to write that in there. And now that the function is really done, it's going to come back to its address, and it is going to jump to the next statement after that. It is going to print 3. Statement 3, it is going to jump to the next line and print statement 4. It's going to do that. And by this time, we have reached the end of our program, and it is going to be popped off the memory, and your program is basically going to end. This is how your program is executed by your CPU. And why am I showing you this? Because it is really good to have an idea of how memory is allocated and used by your program. Another good reason is that some C++ features require you to have an understanding of a memory model like this to understand how they work. For example, you have seen that to call this function, the program had to jump from address 6 to 30, and this is really heavy, especially if you are running a simple function like we are doing here to add 2 numbers. So the CPU can realize that and optimize this call to the function to an inline function and add these 2 numbers up right here at address 6 without jumping to this address here. And this may come in handy, and you need an understanding of this memory model to really understand these features. This is just one example I am giving you. You are going to reuse this model a lot in your career as a C++ developer, and I thought it was a really good idea for you to understand it firsthand. This is really all I had to share in this lecture. I hope you found it interesting. In the next one, we're going to try and understand the difference between 3 key components of the C++ programming language. Go ahead and finish up here and meet me there. In this lecture, I want to highlight the differences between what we call a C++ core language feature, or a standard library feature, or an STL feature, because these are terms that come up a lot if you happen to read some documentation about C++. A core feature is really a basic building block that makes up the C++ programming language. You can think of it, for example, how you define variables, the rules that govern how you can define and use a function in C++, the rules that say what you can do and not do with the basic features of C++. That's really what can be qualified as a core feature of the C++ programming language. I don't know if that makes any sense. If we come back in Visual Studio Code, we have a program we have used in the last few lectures. For example, these basic types that you use in C++, the rules that define how you can define a function. For example, if you put an angle bracket here and try to compile this program, it is not going to work because we have violated the rules of the C++ programs. The basic rules that define how the C++ programming language works, the basic types that are defined in the C++ programming language, these little things make up the raw ingredients you use to make up a proper C++ programs. And these little raw components that you use to put together a C++ program are called core features. You can think of them as the foundation on top of which we really build daily use C++ programs. The standard library is a set of ready-to-use, highly specialized components that we can easily use in our C++ programs. And again, coming back to our program in Visual Studio Code, IOStream here is a standard library feature. String here is a standard library thing we have in the C++ programming language. And again, the C++ standard library tries to provide highly specialized components that we can use in regular C++ programs. When you use the C++ programming language, you don't really want to extend the C++ programming language. You want to use it to build something of your own. And the standard library features are things you use to work on your programs very fast. For example, we have used stdcout without really going into the details of how the data is taken from this program to the terminal. That's really advanced and probably complicated, but it is wrapped into these reusable components, and one of them is IOStream, and we can use it relatively easily in our C++ program. Okay, I hope now you have a better idea of what the C++ standard library is. Now, what is the STL? The STL is really part of the C++ standard library, but it is a collection of container types. Think of them as collections of things. And we have a set of types that allow us to store collections.